Uh, there's some random petroleum jelly on my table. I don't know where that came from. Great. Um, so gonna go ahead and just check if stream is working. Okay, so it's working. We're gonna go ahead and go and go to this thing here called Ziglings. So if you don't know, Zig is welcome to Ziglings. Okay, welcome to Ziglings. Why is it the translation? Why did it say translation? I already changed this. I already changed it. Okay. So, welcome to Ziglings. If you... Ziglings, okay. These are Ziglings. This dinosaur here with the hazmat suit. And this dinosaur here without a hazmat suit. Okay, so... Zig is a programming language similar to C and C++. It's very low level. Zig is very low level, but it's still considered a high level language because stuff. Do stuff with it. But I'm curious about this. The comp time. I think I heard the comp time. Ziglings. Zig is a programming language where you manage the variables yourself. It's a very manual process. It's more manual than Rust. It's as manual as C. Don't get GC. Manage the GC. You destroy the variables yourself. Okay. Those programs need your help. Also save the problem from evil aliens. And what do we have here? Help some friendly elephants stick together, which is very sweet of you. Intended audience. This will be probably a bit difficult if you've never programmed before. Although specific programming experience is required, and in particular, you are not expected to have any prior experience with systems programming. Ooh, scary! Systems programming. Did the YouTube link change? Let me just check. I'm having way too much fun streaming by myself. When there's no chatters with you. Welcome, chatters. Welcome. Okay. I think the video changed. Let's just announce my shit. League? No. I refuse. Please. Okay. This is more exciting for me. Each exercise is self-contained, self-explained. However, you're encouraged to also check out Zig language instructions for more videos. Okay, getting started. I already completed this before our session stream. So as you can see here, we have Zig version 0.17 slash 0.17 0 dash dev here. This is straight from the gym. As far as I can tell. We already have the Ziglings here. I thought I'm gonna be doxxed, but okay. We already have the Ziglings here. And we just have to run Zig build, apparently. So, Zig build. Then run Zig build and follow the instructions to begin. Note the output of Ziglings is the unaltered output from the Zig compiler. Part of the more purpose of Ziglings is to acclimate to reading these versions, advance usage, or skip the random bullshit. Okay, we're gonna go through the Ziglings in order. I'm just gonna drink my coffee. Amazing invisible coffee. Okay, what do we have here? Ziglings. Oh. Broken programs below. Okay, compiling 001. Hello, that's Zig. Error. Why compilation errors? Compilation errors. Compilation. Error de compilation. Okay. Error main is not marked up. Const fn info equals type info. If you don't understand it, I don't understand this. Exercises. Rotate here, fn main void. Call inline here, call main. Start that thing. I don't think this is important because this is part of Zig itself. But you can see here, this is Zig STD. So this is our code, or the Ziglings. This is the Zig STD. CD process exit reference by start comp time to reference incidents f reference trace equals from C all references. Ziglings hint, don't panic. Read the compiler messages above, something about main. Open up the source file as noted below and read the comments. Exactly these application will show up for the most part you'll be taking directions from the Zig compiler itself. Okay. So here the task here is edit exercises /001 hello.zig and run zig build again. I'm gonna disable before we start here. I'm gonna disable our annoying clankers. Where's my new one? You are being disabled. Enabled equals full. Okay. Exercises 001 hello. Let's say. And now, this is supposed to print hello world, but it needs your help. Quick functions are private by default, but the main function must be public. Function is made public with a pub statement, like a bar. Like so. Pub fn foo void. I'm assuming void is the return type. Fn is function. Public function, then the name of your function, then your return type. Perhaps knowing this will help solve the errors we're getting with this little program. Const std equals import std. So this is how you import the std library. It's a standard library. Fn main void. So in Zig you need, because in Rust, right, you don't need the main function to be pumped. But I guess in Zig you have to have the main function pumped. Okay. Okay, so past hello world. Moving on. That's our first. We just advertise here as this is the most important part. Mastodon! Let's move on. Um, let's editing STD. Our errors here are error expected type expression found false. I think this is supposed to be const. Const STD equals import STD. Oops! Program was supposed to be online like our hello world example, but we forgot how to import the Zig standard library. Okay, that's easy. We saw that in the previous example here. So STD equals at import STD. Okay. STD.debug.print. Okay. STD.debug. What's what's gonna be the expression for the non-debug example? I wonder. Oh, here we have just going back to the previous example. This is print. We have the the squarely braces. Squarely. Yeah. For the curious, imports must be declared as constants because they can only be used at compile time rather than runtime. Zig evaluates constant values at compile time. Don't worry, we will cover imports in the later. Also see this ends right here. Okay, this looks cool. Zig build. Quick past. One compilation errors and equals n plus 5. So for the cannot assign to constant. Okay. 3. Our code here is const n u8 equals 50 n equals n plus 5. Talk about this later. I have some experience with the rusting. With the rusting, so I might be familiar with the data types, how to call things. Const pi equals 314,159. Not pi. Pi. Negative 11 equals negative 11. Okay, let's read the beginning first. Our prelude here. It seems we got a little carried away, making everything const u8. What is a const u8? Const values cannot change. U types are unsigned and cannot store negative values. So these are just integers that cannot be negative. So these are your whole numbers. And 8 means the type is 8 bits in size. So you have a bit which can be 0 or 1. This means we have 255 total values that can be stored here because 2 raised to 8 power is 156. Oh, so you have 256 total values. You have 0 up all the way 0, 1, 2, 3 all the way up to 255. That's 256 total values. Stop twitching eye. Let me grab my flashlight here. Shine it on me. Stop twitching. Okay. Just move that glass over here. Oh, okay. Example, if you cannot change it is constant. Bar can change. It's variable. const foo equals u8, const foo colon u8 equals 20 semicolon, bar colon u8 equals 20 semicolon. Example, foo cannot be negative and can hold 0 to 255. Const foo u8 equals 20 bar can be negative and can hold negative 128 to 127. That's const bar. I equals negative 20. And the reason why this is negative 128 to 127 is this still holds 256 values, but we start at negative 128 2's complement. That's the reason. 2's complement. Okay. Example. Who can hold 8 bits? That's 0 to 255. And the bar can hold 16 bits. So 65,535. The maximum value of a U8 is 256, and the maximum value of U16 is 65,535. If you haven't figured that out, it's 2 raised to the power of 60 minus 1, because 0 already took the first part. Well, that's so for here. This is 2 raised to the 8th power minus 1. That's 155. You can do just about any combination of that you can think of. So, U32 can hold 0 out to whatever that number this is. This is 2 raised to the power of 32 minus 1. And I64 can hold this number to this number. So this number right here, the maximum is 2 raised to the power of 64 minus 2 raised to the power of 64 divided by 2. So that's 2 raised to the power of 63 minus 1. So 2 raised to the power of 63 minus 1, that is 9 raised to the power of 8. We're not sure. Fine. 89,000. I'm good there. 89,000. Okay. What did I copy? Anyway. Maybe some other window. Sure. So here we have if we should that's the same number, right? That's 9.22 to the power of times 10 to the power of 80. So that's the same number. Okay. So please fix this program so the types can hold the exact values and the errors go away. Okay. What do we have here? Const and we're adding 5 here, so this shouldn't be const. This should be bar. This is U32. You could be U32. I'm not sure if you can use right. You cannot use U16 because the maximum value is 65,535. So U32 is the next one. And negative 11 should be I. This should fix all our problems. I'm too much time explaining. Okay, for arrays, error expected type expression found close bracket some primes. Okay, go to number 4. Array ba- Array basics. This is new cause the brackets is before the brackets are before the type here. That's new. Huh. I wonder if that makes more sense considering the combine or like say array of some like an array of some say array first before the something. I wonder if that makes more sense. In a compiler speed sense, I guess. R is declared in foo. I think 3 is the size here, size of the array. But there's 3 elements of the array. Var foo of a 3 element Q32 array is a 3 element Q32 array with these elements 4208 and 5423. When Zig can infer the size of the array, you can use underscore for the size and do this with Rust. Fucking my Rust, man. Why can't you do this with Rust? I'm not sure about C and C++. I think you can infer some. I don't think C can. You can predetermine the size, but you can infer it. This is a huge improvement to C if that's the case. Because you can infer the size in C as far as I'm right? You can also let's say infer the size of the type of the values declaration much less verbal. So you omitted the type declaration entirely. Var foo equals infer the size of the array U32. Just these 3 elements here. The values of array index notation is just like other set values from the arrays in array names. That's fine. So C needs to work. Just like JavaScript and C. Get the length of an array using the length property. Do that length. Okay. What's the problem? Sconce is going to cause a problem. Let me see what is how we fix it. I don't see a problem here. Sorry. It's going to cause a problem later. Okay. Oh, cause do we need this to be a var? Is that gonna be the problem? Individual values can set with square bracket notation. Example, this line changes the first prime 2, which is correct. Okay. Some primes, the first element, which is 0, index 0. Individual values can also be accessed to square bracket notation. Okay. What's the problem here? Okay. What did Josh that? Nothing. I don't think we have a problem here. First problem. Let's see. Fourth. Okay, we need to complete this expression using the example above to set the fourth element of the sum prime array. Fourth element is 4. I'm just kidding. I'm just kidding. Okay. Okay. Problem 3. Use the length property to get the length of the array. Okay. Just dot length. Like I think this is code problem. Uh um okay. I think I think okay. I was right. So this is var. Okay, next we have problem 5. How many are these? LS exercises. These are how many files are these? How do I know? How do I know how many? Someone these are arbitrarily numbered. Oh, there are so many. How many is this? Let's see with dolphin. Have you done your Genshin things? 116. Cool. Cool. Okay. Where were we? Okay, number 5. Can we just do this? Number 5, arrays. Zig has one array. Right, okay. Your grammar sucks. You can use plus plus. Okay. Cause in Rust this is just expand. You don't get array operators in every programming language. This is new. You can use plus plus to concatenate two arrays. Const A. I'm not using anything on my. Okay. That's better. Jack, you do the same thing. You can use plus plus to handle arrays. Const A equals this array 1, 2. Const B equals 3, 4. Const C equals A plus B plus 2B. I'm not sure how this flies in memory. But note that plus plus only operate on arrays where the program is being compiled. Special time is known in the parlance as comp time. Okay. This is plus plus only occurs in comp time. That's interesting. Huh. So let's what do we have here? This only works at comp time. Are you sure about that? So we can expand arrays like we do in Rust with plus plus. We can just use this comp time. Okay, lay and add plus 1 through 7. Please set this array concatenating story. Okay. Problem 2, set this array using repetition. This is 3 times this new. Multiplying array. Okay. Oh, this is just integer multiplication. I see. This is just 3 times with pattern unit of length. Bitcast as 3. Uh, uh, oh! Bit pattern unit that learn you it's flat. Bit pattern unit. I guess? It's just repeating 1001. Oh, I need to use commas. This is confusing. If you, if you, if you let me see this, this is confusing. What's that? What is that? At Bitcast, parenthesis, as parenthesis, 3, bit pattern unit learn you 8, at splat, bit pattern unit. Okay. I suppose that only works for ones and zeros. Okay, moving on. Expected function. We need to take care of that. Now that we learned about arrays, we can talk about strings. We've already seen string literals. Hello world, \n. Zig stores strings as arrays of bytes. Const 2 equals hello. Almost asterisk, same as. Say that when things really are in exercise 77. Notice how individual characters use single quotes and strings use double quotes. These are not interchangeable. Okay. Const Ziggy equals Stardust. This is a string, Ziggy. Ziggy is a string. Problem 1 is use array square. Use array square bracket syntax to get the letter D from the string Stardust above. Stardust is 0, 1, 2, 3, 4. Index 4 of Ziggy. Problem 2. Use an array concatenation plus operator to make bigger top. With the add a space as well. Okay. How do we add the space? Plus. How about this? That's all the problems. While we're on this project, C will work in place of you because of personality. Okay, I'm not reading that. Maybe I should. Okay, moving on. Please fix the lyrics. So we're correct with the space. That's correct. I didn't expect that. Here's a fun one. Zing has multi-line strings. Okay, I'm now curious. We have answers. We have answers. Oh! Oh! We're correct! What the hell? What the hell? I'm correct. Okay. Here's a fun one. Zing has multi-line strings. To make a multi-line string, put backslash backslash at the end at the beginning of each line, just like a code comment, but with backslashes instead. See if you can make this program bring some song lyrics. Okay, that's easy. There we go. I didn't expect that some multi-line strings. We don't have multi-line strings in Rust. We have multi-line strings in C, C++. JavaScript, we do have multi-line strings. C plus a C sharp. I'm not sure. Does C sharp have multi-line strings though? I think it does. Okay, 8. So we pass exercise 7. Going to exercise 8. Quiz time. See if you can fix the whole program. We'd have to think about this one a bit. That the compiler telling what's wrong. What the fuck is this nonsense? Note, usize is an unsigned integer type used for sizes. Exact size of usize. Usize depends on the target CPU architecture. We could have used a U8 here, but usize is the idiomatic type to use for array indexing. There is a problem on this line, but usize isn't it. Note, when you want to declare memory without putting anything on it, you can set it to undefined. There's no problem on this line. Following lines attempt to put Z, capital Z, I, and G into the lang array just created by indexing the array letters with the variable x. As you can see above, x equals 1 to begin with. Huh. Lang, so this is a var, because we reassign x. We reassign x here. Okay, got the program in Zig, of course. That. What's the problem here? I see we're okay, so we're just indexing. This doesn't have a problem because it copies Z, the first character, copies I, second character, just 1. X should be 5 here. I'm not sure. This is gonna be Zig even. This is gonna be Zig even. Oh, it's just gonna store in lang though. It's just gonna store the stuff in lang though. That's fine. Okay, moving on. Exercises slash there's there none. Expected type comp time. Now we get into the fun stuff, starting with the if statement. If true, else. Zig has the usual comparison operators such as A equals B equals B, less than, greater, not equal. Important thing about Zig's if is that it only accepts Boolean value, don't coerce numbers or other types of data to true and false. Okay, that's the same with other strongly typed languages such as Rust, uh, JavaScript, and dynamically typed languages such as JavaScript and PHP are very loose with this. They have the concept of truthy and false, coerce the values, Boolean values first before they can they can be used, or they will try to if you don't pass a Boolean value. And if you're not familiar about this syntax in programming, this means this means that this, this is the condition. This is this will run if the condition is true, and this will run if the condition is false. This whole block is optional, and I guess in Zig we have parentheses. I got used in Rust. Let me doesn't run parentheses. I guess it's equals 40. Okay, moving on. 010. If statements are also valid expressions. That's the same as in Rust and CoffeeScript. That's nice. You don't need the cursed ternary operator. Cursed ternary operator here. Okay. This is an if-else expression set price. Discount is to price will be $17, otherwise $20. Yeah. If discount, this is already Boolean. I guess we put parentheses. Then 17 else 20. Okay. Moving on. While statements, remember that the condition must be of value. This messaging rules are. This messaging mean. GS network definition allows filters to use. Right. DJ Khaled suffering from success. What the fuck are you doing? DJ Khaled. What the hell is happening? Valorant. We're streaming Valorant. Germany cuts K season. For $1.5 million Germany! It's the sovereign tech fund, not Germany. Stop with the cold politics. What the hell? Remember that the condition must be Boolean value. That we can get a Boolean value. Boolean value. It really do this? Oh, not like. Please use a condition that is true until n reaches 1024. Print the gunner number and multiply by 2. Okay. So this is just and not equal to 1024. Oh, fancy. While statements can have an optional continue expression. Oh! I haven't seen that before. Which runs every time the while loop continues, either at the end of the loop or when an explicit continue is invoked. Example, where foo equals 2, while foo less than 10, colon, foo plus equals 2, do something with even numbers less than 10. See if you can rewrite that like persistence and continue expression. Oh, so we're just doubling the number, right? That's n times. Oh, it should be an expression, a statement. I mean, that's n times equals 2. Okay, moving on. If n modulo 3 equals 0, what now? No. The list of exercises for functionally identical. The expression executes every single time the starts. Even when a continuous statement gives the rest of the loop body, I want to print every number between 1 and 20 that is not divisible by 3 or 5. Are we doing feasibles right now? I think that's n with 1. I'm tired. Let's end on exercise 20. I'm tired. This isn't fun. I'm learning a lot about Jose. Even when a continuous statement skips the rest of the loop body, I want to print every number between 1 and 20 that is not 3 or 5. This is fine. This is continue. This is a continue. Okay. Okay, next. 14. You can force a loop to exit immediately with a break statement. That's fine. If n is equal to 4, break. Okay. This so far is similar to other languages, the continue and break statements. Behold, the for loop. For loops let you execute code for each element of an array. Okay, do something with item. This is this is okay. Oh, it's happy and sad and neutral. Okay, the end. But the for loops also occur in things called slices, which we'll see later. Also note that for loops have recently become more flexible and powerful 2 years after use exercise was written. More about that in a moment. Okay. For items is the array here. And this is the temporary variable. And this will be seen. Okay. Moving on to exercise 16. For loops also let you use the index of iteration, the number that comes up with each iteration, access the index of iteration, specify a second condition as well as a second capture value. Second condition is you can name item and index anything you want. I is a popular form shortening of index. The item name is often the singular form of the items you're looking through. A sort of bits of binary number 1101 in little endian or the least significant byte or bit first. And the value is U32 equals 0. Now we convert the binary bits of a number value by item value of the place as the power of the bit. See if you can figure out the missing pieces. So, now that we convert the usize I to a U32 with an incast, a built-in function just like an import. We'll learn about these properly in a later exercise. That's at incast I. So place value equals mat.pow u32 to I u32 value plus place value times bit. So what were our generating here? I guess this is I. This is I. Two raised to the zeroth power is first one. This is 0 dot dot. Right? I do apologize if you can't follow my line of thinking. I encountered this before, so that's why. The range operator is also present in languages like Python and Rust. Okay. Moving on to exercise 17. This time again, let's see if we can solve the famous Fizzbuzz. Intersect turns to count incremental increasing any number divisible by 3 with the word fizz and any number divisible by 5 with the word buzz. Let's go from 1 to 16. This has been started for you, but there are some problems. Okay, this is obviously a new one. Let's see. Why? Fine. If I haven't encountered it, I would never I would never have thought this would have Bob in the front. Oh, this is a while loop. Shut up! This is a while loop. Okay. Just print the number. Printing the number right here. Huh. What's this? Why is there... What's this for? I guess that's not important. Oh, okay, that's just prints comma space. Oh, deep song. Can you help write the function? And then functions. Functions. We've already created lots of functions called main. Now let's do something different. F and the foo function above takes a number n and returns a number that is larger by 1. Note the input parameter n and return types are both u8. The new function deep sort should return the number 42. See below. Answer to nerd. Nerd. That is, we don't take parameters, but we return u8. I'm conscious of this contents. Fine. I guess I'll watch Guardians of the Galaxy. What's that movie? What movie does 42 come from? Hitchhikers. I see Hitchhikers Galaxy. Hitchhikers. Guide to the Galaxy. Fine, I'll watch it. Let me just set up the Hitchhikers guide. Okay, where were we? How many reconnects from which? Okay, number 19. Now let's create a function that takes a parameter. Here's for example that takes 2 parameters. As you can see, the parameters are declared just like any other types. That's name, type. Just give the function the correct input parameters. You need to figure out the parameter name and type that we're expecting. Output type has already been specified for you. That's estimate. That's interesting because you pass the type here. U32 is a type, and you're passing it to std.math.pow. That means you can pass types into functions in Zing. That's interesting. Or maybe this is a count time thing, which is also interesting if you think about it like that. Takes a numeric type and 2 numbers of that type or that can converse to that type and to the power of 3 at the same numeric time. That much is understandable from my point of view. This is 2 to the power of 1, 2, 3, and 4. My question is, oh, this is just one parameter right now. That's my number. And U32, I guess. You see, if you can make use of some of the things we've learned so far, we'll create two functions, one that contains a for loop and one that contains a while loop. Both of these are simply labeled loop below okay. You won't see this every day. A function that takes an array with exactly 4 U16 numbers. This is not how you would normally pass an array to a function. We'll learn about slices and pointers in a little while. For now, we receive what we know. This function prints, but does not return anything. Okay. So it takes numbers, doesn't return anything, so that's void. This function bears a striking resemblance in the last exercise, but don't be fooled. This one does the math without the aid of standard library. Okay, that's fine. A standard library is better. Kasi don't look like standard library. It just determines what the best approach for pronunciation is. I think that's how it is. I might be wrong. I want to return the same type. Yeah, because total is U16 and you return total. Why is it called total? Okay, a little bit of grammatical correction here. Total, if you call something total, that's the sum of numbers. Total here is, you can see here, this is a product of numbers. It's just a product. It's just called a product. Oh, that's technically correct. It's not a total. Because total, if we say total, that's the sum of multiple numbers. Anyway, this should be product. This is total. This should be the product. Pedantic. I wonder if the build fails cause change the variable name. Oh, the binary operator responds white space on one side, but not the other. Okay. This is 4. Did I need to correct that? I haven't seen loop. Oh, one contains a for loop and one contains a while loop. Um, is it 4? This is wild. That's a bit confusing if you haven't followed the exercises so far. It's kinda confusing because 4 is used for arrays and well is normal, but we have an iterator here. Occurrence when you continue to, and you typically see that in 4 as well. Okay, stop. We'll end stream. We'll end stream. Be streaming for 160 minutes. Ah, stop. Okay, we're gonna end here. We're gonna continue some other time. There are 100 100 plus exercises here. There's a lot of content. There's a lot of content here. Oh my fucking. Okay. Okay, gonna end stream. I still don't have an end screen, by the way.